This video is for section 5.3. Our objectives in this section are to factor out the greatest common factor of a polynomial, factor out a common factor with a negative coefficient, and factor by grouping. So we're going to start by looking at the greatest common factor. And to find the greatest common factor, we do different things for coefficients and variables. So for coefficients, we are looking for the largest number that all coefficients can be divided by. For variables, we are looking for the smallest exponent on variables that appear in every term. If you have a variable that's in some terms but not in other terms, then it's not part of the GCF. So to factor out the greatest common factor, first you find the greatest common factor and you write it outside parentheses. And then you use the distributive property to find what goes inside the parentheses. So factoring out the GCF, you always want to think about backwards distributive property. If you use the distributive property on what you've factored, then you should get back to what you originally started with. So it's really easy to check your answers for these, and I highly recommend that you check your answers, obviously especially on the test, but you should be checking your answers by using the distributive property to make sure that you get back to what you started with. So we're going to look first at example 1. It says to factor 21x squared plus 28x. So for the numbers, what I want to think about is what two numbers multiply to 21 and what two numbers multiply to 28. And then I'm looking for the largest number that's a factor of both. I know that 21 is 3 times 7. I know that 28 is also divisible by 7. It's 7 times 4. And so now this tells me that they have a 7 in common. And when I look at the 3 and 4, they should not have any numbers in common. Otherwise, 7 would not be the greatest number that they can both be divided by. And if you don't take out the biggest number, then it's going to be the wrong answer. So 7. Then looking at the variables, I see that they both have x. Remember, if you have an x by itself, it has an automatic 1. So the smallest exponent would be 1. So this is going to be x to the first. Now in my parentheses, what I want to think about is what do I multiply by 7x to get 21x squared? Well, I need to multiply 7 by 3 to get 21. And I need to multiply x by x to get x squared. So that term is going to be 3x. Then I'm going to have a plus sign. And then my second term is 28x. What do I multiply by 7x to get 28x? Well, I need to multiply by 4. I don't need to multiply by any x's. So now, when I distribute this back, I should get back to what I started with. And if you do that, in fact, you do. 21x squared plus 28x. So that tells me that this is, in fact, the answer. And again, I highly recommend that you can check these in your head even pretty easily, so I would recommend that you do that, especially on the test, so that you're not getting things wrong. So you should do checkpoint problem number 1 and then move on with the rest of the video. Next, we're going to do example 2. This one has 3 parts, basically just the same as example 1, but some more practice with that. So for part A, we have 9 and 15. So I'm going to think about, okay, I know 9 is 3 times 3. I know 15 is 5 times 3. So they both have a 3 in common, and then this 3 and this 5 don't have anything in common. So I can take out a 3 for my GCF. Smallest exponent on the variable is 3, x to the third. So x to the third can go in the GCF. What do I multiply by 3x to the third to get 9x to the fifth? Well, 3 times 3 is 9, so I need to multiply by 3. And then to get to x to the fifth, I need 2 more x's. So we're using the product rule here. Remember that you're adding exponents when you're multiplying. So that's going to be 3x squared. And then I have the plus sign. And then 3 times 5, I need a 5 to get to 15. And then x to the third, I already have x to the third, so when I distribute this back, I get what I started with. So that's the answer for the first one. Part B, same thing, only this time I have 2 variables. So start with the numbers, 16 and 24. Now, sometimes you might, like if you're just thinking of numbers, you might not think of the biggest number right away. So for example, I know that 16 is 4 times 4, and I know that 24 is 4 times 6. This shows me that they have 4 in common, but when I look at 4 and 6, both of those can be divided by 2. So that means that instead of 4 being the GCF, I need it to be 4 times 2, which is 8. So 16 is 8 times 2, 24 is 8 times 3, 2 and 3, now they don't have anything in common. So that means that 8 is in fact the largest number that they can both be divided by. So that means I can put 8 on the outside. On x, the smallest number of x's that I have is 2. I have x squared and x to the third. And then y, the smallest exponent that I have on y is 3. So that goes on the outside. Now what do I multiply by 16, or by 8x squared y to the third to get 16x squared y to the third? I need to multiply by 2, and then I don't need any more x's or y's. So now I'm going to have a minus sign. To multiply by 8 and get 24, I need a 3. I need an x to get from x squared to x to the third, and I need a y to get from y to the third to y to the fourth. So that's my answer for that. And again, I can check this mentally by distributing. I should find that I get back to what I originally started with. Lastly, here we have part C. In this one, we have 3 terms. So it's important to remember that my GCF needs to be something that all 3 numbers can be divided by. So in this case, 2 means that I can't have a GCF that's bigger than 2. 2 is the most that I can take out of it. So 2 is 2 times 1, 4 is 2 times 2, and 12 is 2 times 6. So they can all be divided by 2. So I'm going to have a 2 on the outside. I'm going to have x to the third on the outside, because 3 is the smallest power on the x's. 2 is the smallest power on the y's, so that's going to be y squared. Now I can go through and say, what do I multiply by 2 to get 12? If you write it out like this, then you're going to have the answer to those questions right here in this area. So multiply by 2 to get 12, I need a 6. I need 2 more x's to get to x to the fifth, and I need 2 more y's to get to y to the fourth. Then I'm going to have a minus sign. Multiply by 2 to get 4. I need 1 more x, and I need 1 more y. Now, in this case, my GCF, is exactly the same as the last term. And a really common mistake is to just stop and say, well, I don't need anything, and close your parenthesis, but what you have to do in that case is you have to put plus 1, so that when you distribute, you get the first term, the second term, and then when you get distribute to this plus 1, 1 times 2x to the third y squared gives you that 2x to the third y squared in the last term. So don't forget that plus 1 if it's exactly the GCF is exactly the same as one of the terms. So that's example 2. You should do checkpoint problem number 2 and then move on with the rest of the video. The last thing that we're going to talk about in this section is factoring out a negative. So if the leading coefficient of a polynomial is negative, then we often want to factor out a negative sign as well. And we're going to see that a little bit later on in some actual problems. So we're going to look at example 3. It says to factor negative 3x to the third plus 12x squared minus 15x. So my GCF, the largest number they can all be divided by is 3, and then smallest exponent on x is 1. So my GCF is 3x, but what I want to do is factor out the negative sign as well. So I'm going to put negative 3x on the outside. Now, you have to be very careful with signs in this and think about, okay, when I distribute it back, am I getting back to what I originally started with? So to get negative 3x to the third, I need to multiply negative 3x by positive x squared. Now to get positive 12x squared, I need to remember that negative times negative is positive. So this is going to change to minus 4x. So when I multiply negative 3x times negative 4x, I get plus 12x squared. And then for the last term, minus 15x, what do I need to multiply by negative 3 to get negative 15? It needs to be multiplied by positive 5. So when I distribute negative 3x, I get minus 15x in that last term. So that's my answer for example 3. Again, same idea, you just have to be really careful with signs. So next, you should do checkpoint problem number 3. Do this problem in your notes, check your answer with the notes that are posted, and then you can move on to the homework.